the step response RC circuit. This is the circuit which included resistor and capacitor. Okay, I would like to share some information to find the step for step response RC circuit. First, we have to find initial capacitor voltage V not positive. Then, second step, final capacitor voltage V infinity, which is DC voltage across capacitor. The third step, the times constant, it is tau. Tau equal to RC. This is the final formula for step response RC circuit. Vt equal V infinity plus V not positive minus V infinity exponent power of negative T over tau. First step, we have to find from the circuit. We can see when the T is equal 0, the switch moves to B. So we have to find the condition when T is lower than 0. When the condition T is equal to 0, the switch is at position A. This is the circuit. We have 10 volt power supply, 4 kilo ohm resistor, 8 kilo ohm resistor and 20 microfarad capacitor. Okay, during T is lower than 0, capacitor act as open circuit. At this time, I is equal to 0 because there is no current across the circuit. Okay. So we have to apply voltage divider rule to find V not negative at the capacitor because it is parallel with the other side. V not negative is equal to 8 kilo ohm over 4 kilo ohm and 8 kilo ohm times with power supply, which is 10 volt. We get 6.67 volt. As we know, V not negative is equal to initial capacitor voltage because voltage cannot change suddenly.
So is our circuit during T more than 0. So to find V infinity, we know that capacitor act as open circuit. So to find the voltage drop here will equal to V voltage. By using voltage divider rules, so at voltage divided at resistor at 12 kilo ohm to find V infinity at capacitance. So this comparison. Therefore, the voltage infinity is equal to negative volt. Then let's move on to third step to find tau or time constant. So the formula is R equivalent times capacitance. So to find R equivalent, we know that 12 kilo ohm is parallel to 24 kilo ohm and 2 kilo ohms series to their resistance. Therefore, R equivalent is equal to 10 kilo ohm. So using the formula, 10 kilo ohms times 20 micro equal to 0.2 second. Time constant. Let's carry on to the other side. Therefore, by using the formula, we know that V infinity is negative 5 plus to V naught 6.67 minus negative 5 square of exponent power of negative T over 0.2. 0.2 is tau. So the answer is Vt equal to.
So this is simulation for RC circuit from the question given. So I already put a oscilloscope at the capacitor and multimeter at capacitor to show the value of voltage. So let's start the simulation. So this is T during lower than 0. Then we switch, find T over more than 0. Is to find the steady state from this circuit. And this is the final one. The steady state from this circuit, the voltage will give negative 5. So the oscilloscope will give this type of output. Yep.
Hi, Assalamualaikum. I'm SYAFIKAH from BEEI, semester 2. Today we want to discuss about second order circuit. So we have 4 second order circuit. The first one is the source-free series RLC circuit. Second one is the source-free parallel RLC circuit. The third one, step response of series RLC circuit. And another one is step response of parallel RLC circuit. So today we want to discuss about this source-free parallel RLC circuit. For natural response, we have 3 cases. The first one is overdamp, second one is critical damp, and the third one is underdamp. So before we know the case, we need to identify the value of alpha and omega naught. So for overdamp, when alpha is greater than omega naught, for critical damp, alpha is equal to omega naught, and underdamp is alpha less than omega naught. So this is the circuit. We have resistor 1.923 ohm, inductor 1 Henry, and capacitor 10 microfarad, millifarad. Okay. This is how we want to get the alpha and omega naught based on the equation they want. So the equation is find BT for T more than 0, assuming V naught 5 volt, I naught is 0, and the value of R, inductor and capacitor. Okay, formula to find the alpha is 1 over 2 RC. RC is given in the script. Okay, so here 1 over 2 times 1.923 times 10 milli equal to 26. So we know the value of alpha is 26. So this one is for omega naught. Formula for omega naught is 1 over Z LC. LC also given in the equation. So 1 over Z 1 times 10 milli, we will get 10. So the value of alpha is more than omega naught. It is categorized as overdamp response.
Since we get the value of alpha and omega naught, so we calculate for the S1 and S2. Okay, for S1, this is the formula, negative alpha plus square root alpha square minus omega naught square. Okay, so we put the value, okay, and we get S1 is negative 2. Okay, for the value of S2, okay, this is the formula, negative alpha minus square root alpha square minus omega naught square. Okay, we get the value is for S2 is negative 50. Okay, so this is the equation to find BT for overdamp response. Okay, BT, the equation is A1 exponent S1T plus A2 exponent S2T. Okay, so this is the value for S1 and S2. S1 we get negative 2 and S2 we get negative 50. Okay. Then we have to find the value of B naught. Okay, the value given 5 volt. Okay, so 5 equal to A1 plus A2. When we want to find A1, 5 minus A2. Okay, we have to find the dV over dt. Okay, this is the formula, negative V naught plus Ri naught over Rc. Okay, the value of V naught is 5 volt plus 0 over, okay, this is the value Rc. Then we get negative 270 volt per second. Okay, so we have to find the BE. Okay, this is the equation. So then we have found the dB/dt. Okay, so the value is negative 2a1 exponent negative 2t minus negative 50 a2 exponent negative 50t. Okay, so we have to t2 substitute to 0 when t is 0. Okay, so the value of dB/dt is negative 260. Okay, so this is the equation. When we put t is 0, when exponent equal to 1. Okay, so we get this negative 2a1 minus 50a2. a1 we have to substitute this. Okay, 5 minus a2. So we get enter the value. Then we get a2 is 5.208 for a2. Okay, so the value for a2 is 5.208. Okay, so this is equation for a1, 5 minus a2. Okay, when we want to find the a1, so we enter the value for a2, 5 minus 5.208, and we get negative 0.283. So the final answer for the BT is negative 0.2083 exponent the power of negative 2t plus 5.20x exponent power of negative 50t volt.
This is RLC circuit. So I will show the simulation of RLC circuit from the question. We start here. Simulate using analysis and simulation. Using transient and set to 0. Start from 0 and time stop is 1.5. Just run. So this is what happens if the circuit is overdamped. Let's find one. So to prove that the circuit is overdamped,